I I think we can get started. Good afternoon, good morning, good evening, wherever you are in the world to everyone, and welcome to our monthly webinar. We'll be talking today on an introduction to Docker containers and Kubernetes with David Fox, who'll be giving our presentation. Now, David, I will hand it over to you.
Cool, thank you, Mark. So again, my name is David Fox. I'm in the NetApp IT department. I've been with NetApp about 8 years, and as Mark just said, we're going to talk a little bit about Docker containers and Kubernetes at an introductory level. So with that said, what exactly are containers, right? Fundamentally, containers are a way to distribute applications as immutable images, right? And this allows you to essentially leverage one Linux server to host multiple applications. And you could do this in a way where the application is separate in a certain sense from other applications running on that same server, but also the server hosting the applications themselves. This uses a feature of the Linux kernel called C groups, which is short for control groups. And that provides that file system, network, process isolation that allows your containers to run independently of each other, giving you an extra level of stability and an extra level of security that you just wouldn't have, say, if the application ran straight on the host operating system. So one of the most common questions I hear are, how do virtual machine containers differ from virtual machines, right? Well, the first reason is, or the first difference is that containers are just more lightweight, right? When you think about a virtual machine, you've got the operating system itself running, the kernel. Then you've got all the system services that run on top of the operating system. So think SSH, any monitoring agents you have, any APM agents you have. And then, of course, you've got the application, right? With a Docker container, you're only running one thing in that container, right? And so you don't have all the agents, the Linux kernel itself to worry about. You're just containerizing the application. The second difference is that unlike virtual machines, containers are immutable. So what I mean by that is if you execute a shell inside of a container and you delete /usr, right? Normally that'd be a bad thing on a virtual machine, right? That virtual machine's going to cease to work. It's not going to come up. It's not going to reboot, right? In a container, if you do that, exit the container, kill the container, and restart it. And what you'll notice is that /user comes right back, right? And that's because, again, we're delivering the application as an immutable image. So any changes within the container are essentially discarded once the container exits and restarts. The third key difference between a virtual machine and a container is the repeatability factor. And what I mean by that is when you have a containerized application, you can install that immutable image of your application on 1, 10, 1,000 machines, and it's going to come up the exact same way every time. It doesn't matter what the host operating system looks like. You know, your application is going to be ultimately or utterly repeatable. With a virtual machine, yeah, typically those will come up from like a golden image, right? So they start out the same, but because they're not immutable, because they're actually mutable, you could change them. They don't stay golden for long. And so that means, you know, when you're deploying applications, especially applications at scale, and you use the virtual machines, you'll have a lot of configuration drift, meaning that your repeatability just it's not there, right? You have certain machines that are going to be configured different than other machines for whatever reason, user error. Maybe there was a problem with an installer. Maybe somebody had to make a change as part of a debug session, but the repeatability for whatever reason just isn't there because you don't have that immutable image distribution source. Another key difference: images are just easier to maintain. Really, what we mean by that is that the image author maintains the image, so any updates or changes that need to go into the image are made once, and then you distribute that updated image down to your servers, right? So it could be one server, 10 servers, 1,000 servers, right? everybody's getting that same update at the same time. So you're just updating it in one place and generally pushing that to what's called a Docker registry, right, for everybody to consume. With a virtual machine, that's a lot harder, right? You've got to patch them, and then once you patch them, you've got to reboot it, right? And again, because we're dealing with systems that are mutable and people that are manually operating it oftentimes, right? You often end up again with configuration drift. Some systems might not come up after a reboot, some might come up but not act properly. So they're very, relatively speaking, hard to maintain relative to a container. And lastly, containers are just easier to deploy, right? When you think about what it takes to get a virtual machine with an application on top of it, in many IT shops, you're looking at sometimes days or even weeks to do that in a lot of IT shops, right? With a Docker container, once you have your Linux server that's able to run Docker containers, it's pretty easy to spin up an application, right? Docker run my application. That's it, right? So it's much easier to deploy container images relative to virtual machines in many shops. So let's talk about life before deployment of applications as containers, right? There was a time back, I think it was Docker's been around since 2012, right? Where realistically, if you needed an application, the only way to do it was to put it on quote unquote bare metal. Either that's a real bare metal server or a virtual machine. First step, get your machine, right? Again, this could take, if it's a pretty efficient IT shop, like we have a NetFIT, this could take 15 minutes. It's not so bad. Other IT shops, you're looking at days or weeks potentially, right? So you get your server, you set up the server and maintain that server to the specific level or operating system that your application requires. So for example, maybe this application requires you run RHEL 7 or Ubuntu 2004 or what have you. You've got to set up the server specific to your application. And again, the server is a mutable resource, meaning that if you're doing this at scale, as you're getting your servers and setting them up, either through operator error or a problem with the installer or what have you, some systems might look different than other systems, which could bite you in the future, right? Then you have to deploy your application, right? That takes a while. If you've got automation in-house, such as Ansible or Chef or Puppet, this might make it a little bit easier. But still, you're looking at best several minutes if you're using automation, to several days or weeks if you don't have any automation or if you've got a very complex application. All this is really hard to maintain. With containers, though, the game really changes, right? First up, you still have to get a server, right? A Linux server that's able to run Docker, which is all modern Linux distributions nowadays. Again, that could take some time depending on how efficient your IT shop is, right? 15 minutes for us in NetApp, maybe longer for you. Once you get that, you just set up the server to run Docker containers. In the case of Red Hat Enterprise Linux 7, for example, that's yum install Docker, right? And that's all it takes. And from that point, you're ready to run containers. So Docker run my container. That's it. So you're cutting out a lot of that work that you used to have to do when deploying the application straight to the virtual machine. Now that you're able to containerize applications, and this makes everything very easy to maintain. So, okay, the advantages are clear. Docker containers are easier to maintain. They're quicker to spin up. Just makes life easy. How do we do it, right? Well, the heart of building a Docker container is what's called a Dockerfile. The Dockerfile will reference essentially a bunch of steps that goes into baking a container, right? It'll reference a base image, and then it'll have other steps such as package updates, installing the application, configuring the application, what have you. On the right-hand side, I have an example called Pleroma, which is a distributed microblogging platform. And you can see here that is coming from a base image called Elixir, which is out on Docker Hub. It's an image that somebody else built. On top of that image, we're running some package updates. We're adding a group and adding a user. We're making a directory. We're cloning the application out of a Git repository. We're putting a configuration file in place. We're then building the application. And then that final stanza, CMD, that is saying, this is how you run the application every time. So once this image is built, it's going to run precisely what goes into this image this same way every time. And then once you have it built, you can then push this image to a container registry or repository so that other people can consume it, either within your organization or the public at large. So running the container, how do we do that? Now that you've built it, you obviously want to run it. Well, the first thing you do is, you're going to use Docker run. You specify the image you want to use, and you pass in parameters, potentially, right? And this will depend on the application, right? So for example, if you've got Nginx or Apache, you might want to pass in that certain network ports should be passed to the container, for example, 80 and 443. Or if you've got a container that needs to leverage some, say, static web files, for example, you might pass in a volume to use. You could pass in environment variables for your application, or container capabilities, such as this container needs to run as root for some reason. Not a good idea, but you could do it. There's some applications such as Keep Alive D, which keeps an IP address floating between two machines that has to run as a super user. So in situations like that, you pass on the capability that says, run this as super user, right? There are other capabilities out there, but the idea here is that you're just passing in an image and some parameters, and your application just runs. On the right-hand side of the screen, I'm running an application called BusyBox. It's really a diagnostic tool a lot of people use just to look at volumes and stuff in a containerized environment, but it does illustrate one of these capabilities really well. If you see, the first thing I do on the right-hand side of the screen is I look at a file system space on my computer, right? Home cloud user temp, right? It has some files in it. I want to pass that inside of my container. So what do? I do Docker run /v for volume, and I specify I pass in /home cloud user temp and present it to the container at /mnt. And then -it, make it interactive, give me a terminal, and then -rm, once the container exits, remove it. And BusyBox, that's the container image, right? So once I run that command, it drops me into a shell inside the container. And if I look at /mnt, I can see the same files within the container that I see on the host, right? So this illustrates the ability to pass in volumes, right? But again, you can specify, network ports, other capabilities, environment variables, all sorts of things that your application might need to run. So containers is pretty easy, right? Just get a server, Docker run. That's all there is to it. Well, not so fast, right? With containers being so easy to run, you tend to have a lot of them, right? So just like once virtual machines became prevalent, you had what was called virtual machine sprawl. Now that Docker containers makes applications easy to run, you're going to have container sprawl. So how do you do things like deal with server failures, right? So an example of BusyBox, right? Where I was passing in a volume, right? Let's say the server goes down. How do I deal with that? How do I run BusyBox somewhere else? Is there an automatic way to set up networking? So for example, if you've got two Nginx servers or two Nginx containers rather, both of those can't run on the same server and use port 80 and 443 on that server, right? So there needs to be a way to intermediate that, right? So that you can have two Nginx's where, something's listening on port 80 and 443 and traffic for container A goes to container A and traffic for container B goes to container B, right? What about the data, right? So running containers on another Linux system is really easy, right? But moving the data, that could present a challenge, right? What if the container terminates for some reason? Applications have problems, right? They crash. Uh, how do we deal with restarting that container automatically? If the server goes down, how do we deal with restarting that container on another server? And lastly, how do you scale out, right? So, we don't want to, necessarily um, uh, manually have to build a bunch of Linux servers for every application, right? There's got to be an easier way to do that, right? Like maybe a pool of Linux servers that applications can cohabitate on and move to as needed. This is where Kubernetes comes in, right? Kubernetes is essentially a system to automate the scheduling of containers on worker nodes, right? So you want to run your Nginx, and expose 480 and 443, such that www.myapplication.com will always go to that container. Kubernetes takes care of that scheduling work of running the container. It provides that networking layer that you need, right, to make sure that www.myapp.com goes to your new Nginx container or Node.js or whatever, right? It presents the data needed on the container, needed by the container, no matter what host they live on. So if your Nginx lives on worker host A, it's going to have the data that it needs, right? If worker host A goes down, that workload can now move to worker host B. Kubernetes makes sure that data is presented to that container on that new host. Scale out capabilities, right? So you start with one Nginx, right? But hey, the holidays are coming up, so you need to scale out. Kubernetes has methods by which to automatically scale out to meet that new demand requirement. And lastly, an ability to restart the container if it terminates for some reason. Either the server going down, the application having an issue, or some other reason, right? Kubernetes has ways to check on the application, see that there's a problem, and if there is a problem, terminate the application and restart it either on the same host or a different host. So how do you deploy applications on Kubernetes, right? Well, first you need the Docker image, right? You've got to be containerized, obviously. But once you're containerized, you can reference your container image in what's called a manifest. These manifests are either in JSON or more commonly YAML, just because YAML is easier to read. These manifests can create all sorts of things. The container deployment itself, like we have in the example to the right, data volumes, network components such as load balancers and ingress, scheduled tasks. All these things are created via Kubernetes manifests, right? And typically the way that you apply them is with a tool called kubectl. So you would do kubectl apply /f your manifest, and to the right again is an example of a manifest. This is a tool we built in house to debug HTTP headers, right? So we built the image, we deploy it via this manifest. We have other manifests for our other things again, such as networking and ingress, and from there our deployment's done. So now you've got a bunch of Kubernetes manifests, right? How do you maintain that? How do you lifecycle manage this application on Kubernetes, right? This is all going to be part of a part 2 of this series relating more to CI and CD, where my colleague Jonathan Fair, he'll walk you through what we do and some of the general principles of CI and CD. So that's my introduction for Docker and Kubernetes. Hopefully that was helpful. And if there are any questions, definitely feel free to ask. Thank you.
Yes, everyone, please do. We'll take any and all questions now. One question, are containers similar to LDOMs, LDOMS?
LDOMs, is that Solaris
Oracle.
Oracle? I'm not familiar with LDOMs, but as I recall it, um, there's not a lot of similarity there, as I recall.
Okay.
I'll be honest with you, though, no expert on LDOMs or Oracle.
Are we covering container security in the upcoming sessions? That is on our list for consideration. Boy, I got lots of questions coming in now. Are you using more Docker files or Docker Compose files?
In our environment, we actually use Dockerfile to build the image, right? But to actually deploy Docker Compose, we're not using, right? We're strictly a Kubernetes shop, so Docker Compose would not be a tool that we would use. Although with Kubernetes, you can consume Docker Compose files with a tool called Compose with a K, which essentially takes your Docker Compose YAML and transforms it into Kubernetes manifests.
Mm-hmm.
So we could, but we just don't.
More questions on future subjects for everyone. We are constantly looking for new things, so you are helping us do that. Does Kubernetes offer visibility into CPU and memory statistics or general health?
Well, so there are kubelet checks, and all the checks must come back as okay before the kubelet will be called healthy and the node will be marked as ready, right? Those are, I think it's a file system, memory, there are two more I can't recall off the top of my head, but there are a total of 4, right? As far as like CPU utilization, no, kubelet doesn't care about that. But with that said, what the Kubernetes scheduler does care about is the placement of workload based on what's called resource requests. So we didn't really talk about this earlier, but resource requests, when you deploy an application, your application can quote unquote request a certain amount of CPU. And think about a request as almost like a reservation. And what the scheduler would do is try to find the best node for your application relative to all the other applications and their relative requests, right? And if there's not enough CPU available for your application across the cluster on any given node, that application will fail to schedule, right? So while the kubelet doesn't care about the CPU usage on the system, does care about CPU requests, and that could definitely impact how your application schedules.
Very good. How is Kubernetes storage different from a block storage or file storage systems?
Well, it's not different because Kubernetes really doesn't do anything in terms of storage. It leverages dynamic storage provisioners, which present the storage to the application. All the Kubernetes really does to facilitate that is provide a framework, by which applications can request storage and dynamic volume provisioners can provide storage, right? So Astra Trident, which is our product, is one of those dynamic volume provisioners, right? Astra Trident, based on your persistent volume claim manifest, can present you with either block storage or, and that's in the form of iSCSI. I think they support Fiber Channel, so they could do all sorts of block storage, or NFS storage, right? Which is from what I've seen the most common.
Do you see a fit for cloud data sense for security needs?
I'm not familiar with the product. Um, so I'm not really sure that I can answer that question. Well, I can say this: what we use. Well, maybe I probably can't say that. So scratch that. So I'm not able to answer that question. I'm not familiar enough with the product.
No, not a problem. Not a problem. Um, if they can run on, or how can containers run on a Windows system?
Um, that's a great question. I know that they can. I've personally never done it before because, frankly, in our environment, there's just not been a demand for containerized application on Windows. I know it's possible. Uh, how that works, if for example, you can have a Windows worker node in a cluster that is also composed of Linux worker nodes, or if you need to have a dedicated cluster, I'm not, to be honest with you, too sure on the ins and outs of that.
Okay. Um, are there any good like online spaces where you can get your hands-on work with containers or Docker or Kubernetes?
Yes. Anything from, I mean, it depends on what level you want to come in at. If you're like very fresh, you want trading, you can go to some of these online training solutions. Like Udemy is one that we've used internally. They have hands-on workshops. If you just want to get your hands dirty, um, DigitalOcean is good and cheap. It's what I use for like all my like home lab projects. So I'd recommend them. And then of course, Amazon has a solution. It's going to be more expensive, like for just tinkering, as it were, than say something like DigitalOcean or Linode. But it is an option right there. And if you keep your sandbox small enough, I'm sure it'd be relatively cheap.
Right. Um, uh, can you configure cron jobs inside container?
You can, but what you would normally do inside of Kubernetes, at least, is what they have. It used to be called cron set. Now I think it's called job set. Um, and that's essentially the scheduled running of a container, right? And the formatting of that schedule is just what you would find in, say, your cron tab.
Okay. I got one for me.
Okay.
What's the difference between deploying applications on a host versus a container?
Well, that goes back to the slide from earlier, right? The when you deploy an application on a host, right? It it's a first of all, it's something that you're going to have to maintain sort of kind of in lockstep. So, for example, if your application requires RHEL 7, you can't run RHEL 8, you can't run Ubuntu, right?
Mhm.
You've got to run the host operating system precisely the way that your application wants it to be run, right? So say the precise patch level, with the exact packages that are needed, and if there's any deviation, you're going to have problems. With a container, all of that user space stuff that the application needs is baked into the container. So if they need a certain Java, if they need a certain patch level, if they need, if they need the user space from RHEL 7 or CentOS 7, whatever, they're going to bake that into the container. That allows you to run the host operating system however and using whatever you want, be it Debian or CentOS or what have you, right? The application is really separate from the host operating system, which gives you a lot of flexibility.
Okay. Well, let's see here. Any thoughts about Kubernetes dropping the Docker runtime?
Uh, well, I mean, it was bound to happen. So no, I think that Docker Shim was a thorn in their side from upstream perspective for quite a while. From an end user perspective, like be it our developers in NetFIT or NetApp Business, and from my perspective as a platform administrator, it's really not going to make much of a difference. Like the container runtime can realistically be anything. It can be Podman, it can be Cryo. It just can't be Docker now because the shim's being removed in 1.22. But I don't think it's going to really impact anybody because the runtime is frankly sort of kind of irrelevant.
Right. It's no one just for me. Like, what's the role of a load balance in Kubernetes?
So you've got a manifest or type called service, and that service could be one of several types. It could be host port, node port, or load balancer. What the load balancer does is it presents an external IP to interface with your application, right? And that external IP will load balance across all of the applications that have a certain application selector label, right? So if you have, let's say 4 pods that have labels of app equals X, right? When somebody hits a external IP provided by server-side load balancer, it's going to actually load balance across all the pods that have that app equals X label set. So does that answer your question?
Yeah. I guess kind of one final question just for me. What can be done to increase like security in Kubernetes?
Well, there are things like just good container hygiene, like using tools such as Twistlock to ensure that your images are indeed secure. So that's the first thing, right? That combined with an emission controller to enforce certain security standards, such as deployment should not run as root, for example, or any other security policy that your organization might want. Between keeping the image itself secure and having an emission controller enforce security standards, I think those are really the two things that you can do to make sure that the way that you're deploying your applications is done in the most secure way possible.
Very good. All right. Well, I believe we've answered all questions. If there's any others, I get them in now. Otherwise, thanks, David. This has been fantastic. I learned a lot. I hope everyone else learned a lot. Yes, we will be sending out a recording of this as well as the slide deck later today. So if there are no other questions, I will wish everyone a wonderful rest of your day, and we will see you next month.
Cool. Thank you.
Thanks, David.
Thanks, David. Thanks, Paul.